Hello and welcome back to my Blind 75 Python solution series. Today we are going to be taking a closer look at LeetCode question 153, also known as find minimum in rotated sorted array. This is a medium level question, and I will be solving this using first the two-pointer technique with a little bit of dynamic programming in there as well, and then again I'm going to be solving using the binary search. And then I'm also going to be doing one more bonus solution, which is kind of a sliding window-ish approach to it, and I'm going to talk about that a little bit more as well. To tell you a little bit more about what the time and space is of all these solutions before I solve the problem, the two-pointer and sliding window solutions are going to have O of n time and O of 1 space, and the binary search answer has a O log n time and O1 space. So the binary search answer is our fastest solution to the problem, but any of these approaches is good. As long as you're able to solve this problem, that's all that matters. So even though, as I said, the techniques are a little bit slower, I want to talk about them anyways because in a real interview, you're better off solving the problem even if it's not the fastest way to do so. So if this is the solution that comes up in your brain because it made more sense to you, that's really all that matters. If you're able to solve that problem, I just want you to be able to solve it in whatever way makes sense for you. But before we read through the problem, please take the time now to subscribe to my channel and like this video. It really helps me out and is greatly appreciated. All right, sweet. So now let's read through the problem. For the problem, we have suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the nums array 0, 1, 2, 4, 5, 6, and 7 might become this or that, depending on how it was rotated. So what this means is that when you have this rotation, all we're going to be doing is if you have 1, 2, 3, 4, it's still a sorted array, and that's important to keep in mind because the sliding window type solution and the binary search type solution require a sorted array. So if you don't have a sorted array, those solutions will not work. And they also work for rotated array, which is basically like a cyclical sorted array. So it's still in a cycle. If you went from the end of your array back to the beginning, it's still in order. So if we had this one, it might end up being instead 4, 1, 2, 3. So that's the only difference. So still sorted, but just in order. And then given the sorted array nums of unique elements, return the minimum element of this array. And we must write an algorithm that runs an O of log time, which we're going to do, but I'm also going to show you the solution that doesn't do that. They're only saying that because they want us to solve it that way because it's the fastest way to solve it. But that's no fun just solving it one way, so we're going to solve it a couple different ways. So without further ado, let's get started in solving the problem and let's look at a little quick demonstration. So this is our first solution that we're going to be doing, and it's going to be the two-pointer technique, which is what we're going to look at first. As I said before, this is an O of n time, so this isn't really what the LeetCode solution is looking for, but this is another way to solve the problem, so that's why I kind of want to go over it. And I think it makes a lot of sense, and you'll see why when we code it up later. So what we're going to do here is we're going to create these first 3 variables. We're going to have a start variable, an end variable, and the min num variable. And that's why I said there's a little bit of dynamic programming in this approach, because this min num variable, we're going to save it over time. So we're going to keep saving that minimum value that we're getting from our numbers, and then we're going to do a comparison. So that's kind of how it adds a little bit of that DP into there. And for our start variable, we're going to have our start variable begin at the beginning of the array. So this right here is going to be start, and then our end variable is going to be end. And when we actually program this problem, the start and end variables are actually going to be by index, but to make this a little bit simpler, we're just going to put it as 3 and 2. And then the min number right now is going to start as nothing. And I'll show you how to code that up later, but just know that this is not anything right now. It's just some positive number, but it's not currently anything. Let's take a look at how we're going to solve the problem. So let's take a look at the steps. So what we're going to do is we're going to check if start value is greater than the end value. That's our first step. Then step 2, if it is, set the min num to the minimum of the current min num versus the start value. Step 3, we're then going to decrement the end value. Our else statement is if start wasn't the minimum value, so wasn't, then do the same thing as step 2, but compare with end value instead. Then, if that's our solution, if that's what happened, we're going to increment the start value. And then at the end, we're just going to return min num. So let's get started with the problem and do the first loop. So our current pointers right now is at the 3 and the 2, so the start and the end. So we can put these down here, which is just going to be 3 and 2. And then all we're going to do for that min num is we're going to compare our current num, which is nothing, so it's nothing, just some positive number, versus which number is our smaller number. It's going to be the 2. So it's going to be nothing versus 2. And because we currently have nothing there, 2 is going to become our minimum value. So we're going to get rid of that and we're going to put 2. And because the smaller number was on this end side, we're going to move the end over. We're going to decrement it by 1. So we're going to move that end over and we're going to put it right here. Now we're going to do the same thing here. So now our start value is still at 3. Our end value is at 1. Which one is smaller between those? Is it 1 or 2, which is up here, the 2 right here? Of course, it's going to be 1 is the smaller value, so 1 is our current min value. And because once again, end had the smaller number, we're going to move that end over again. So now our start is still 3. Our end is now 5 because we moved over, we decremented again. 3 versus 5. Obviously 3 is smaller versus the 1 though, which is our current min num, which we'll set this right here. We'll move these over as well. So we're at 3 and 5. Our 1, of course, is still going to be smaller, so that doesn't change. Now, because our end is actually bigger, we're going to move that start over. So start is now 4. So we got start and end. So start was 4, so it's going to be 4. So we got 4, we got 5, and then we got 4 versus 1. And obviously 1 is smaller. So what are we going to do? We're going to return our 1 value. And we're done. And that's our answer. And that's how we'd solve with the 2-pointer technique. Okay, so first things first, we're going to code up our find min solution for our 2-pointer technique. And first thing we're going to do is create an edge case in the situation that the nums array only has 1 value. And you can include some other edge cases as well. I know some other people did on LeetCode in their answers, but it's not necessary. But you do have to add this edge case for this solution to work. Next, we're going to set our variables that we talked about in our demonstration, and they will be at the start and end of the array. We also want to set the min num variable, which we are going to set to be just some positive number. So let me write a little bit of that out right now. Min num, and it's going to just be equals to len nums with float. Oops, and then let me have this -1 here, and then float INF. And the INF just stands for infinity, and you can't set it to 0 because that will become your automatic min num. You have to use the INF instead to be able to just hold place for some positive number we're going to get in the future. And you can't write negative INF in this case because we have no negative values in the array. So we don't have any of those, so it would not work if you use that instead. And we're going to write our while loop. While start is less than end. And for the 2-pointer technique, you want to use the while loop that ends when the pointers are about to equal each other. So this is just standard for 2-pointer approach. So then all we're going to do next is just compare our pointers. And in the case that the start value is less than the end value, and you can do this vice versa, it doesn't really matter, but we're going to do start less than nums end. And then next we're going to set our min num value from these values. So we know that start is less than end, and then we're going to do our min num that we currently have versus our nums start value. And this is where I was saying that there's a little bit of dynamic programming in the approach, because we are going to save that value from this sub-problem. So every time we loop, we're going to save a value or see if we need to save the value. And we're going to be saving it up here in this value here. And then all we have to do after that is decrement down in this case, because we know that if the start was less than the end, our min-num value is going to still be more over to the left side. And then we're going to do the else statement, which is just the other half of that. So equals min number, min-num versus num's end. So just the same thing as we did before, but in the case that, end was less than start, our num's end would be the number that we'd be evaluating instead versus our min-num. And then after that, all we're going to do is increment start, because we know that if our end value was less than our start value, then that means that our value that we're looking for is going to be on the left side. And then at the end, all we're going to do is return min-num. And that's it. That's our two-pointer technique. And what's cool about the two-pointer technique is this technique will work with any list. It doesn't matter if you use this list with, and it's going to be find min instead. And then we can just return it and we get our answers. Just like that. Super easy. So this is the two-pointer technique way to solve the problem.